All right. Hey everyone, welcome to the stream. Gonna say hi to those in chat, to Meshu and ABD. Thanks for joining, and thanks for waiting a little bit. Just had to set up stuff because my machine rebooted. So yeah, a couple nights ago we were working on getting the game. Oh, sorry, I just forgot something here. Getting the game. What's it called? Clean Sweep. Oh yeah, that's it. Clean Sweep, which is basically the Pac-Man clone for Vectrex. Meshu says Linux is greater than Windows. Yeah, no, I won't argue that. As I said before on the stream, I use Windows primarily because I'm a game developer, and so I use this at work and kind of sort of have to. But one thing for sure is I will be porting Vectrexy to Linux at some point, and I'll be doing that on stream. So that'll come at some point, and probably not too far off into the future. So yeah, so in case you didn't catch last stream, I was working on Clean Sweep. Yeah, so Visual Studio is great. Now in Linux, you could use Visual Studio Code, which is pretty cool, right? Which is what I use as my text editor, and it's pretty good, right? And otherwise, if you want, you can always use Visual Studio to debug Linux. I don't know if you know about that, but in Windows 10, you can either install the subsystem, the Linux subsystems that they've added, which allows you to run like a real, a native Ubuntu within Windows, or you can actually use a VM like VirtualBox or whatever. And Visual Studio has this like awesome plugin for Linux debugging. VS Code locking your computer. Yeah, so I don't know if you've seen this there. Like if ever you have to if you want to use Visual Studio and debug a Linux project, they have some serious support that they've put in there for that. This is actually from Microsoft themselves. It's not like some third party or anything. They actually added a ton of real support into Visual Studio, and you can see you have like a remote GDB debugger thing here. It's pretty cool. Actually, I used an early incarnation of this at some point to debug a Raspberry Pi application, and it was quite cool. So if you like Visual Studio and you like Linux, you can kind of do both. So yeah, like we were working on this, and what we saw was that Malban, the author of the excellent VIDE or VID, or I don't know how you pronounce it, he wrote an article about the difficulty of emulating this game, primarily because the game does its own rendering of the maze, and it does that with a lot of very it kind of bypasses the BIOS and does its own thing, and it relies very much on the very specific timings of the analog hardware. So what I mean by that is, like, when you think about the Vectrex, right? You've got the CRT, and the way the Vectrex works is that you feed these values that drive the X and Y integrators that move the beam around the screen. There are delays, like actual hardware delays, and how long it takes the beam to start moving. When you tell it to start drawing, at the moment it actually turns on the beam, the moment it turns off the beam when you tell it to stop drawing. And these delays that are very hardware specific and can actually vary from, say, screen to screen, even for the same type of screen. The BIOS, for the most part, makes up for that by introducing a whole bunch of extra delays. So just to make sure, the beam should reach here in this much time, but we'll spend more cycles just to make sure it's there. That's something that's done in the BIOS routines, but for Clean Sweep, they decided not to do that because they had to draw so many more lines on screen in such a limited amount of time. So they went and kind of tweaked their algorithm for drawing so that it looked just right on the Vectrex, and it looked pretty much the same on most Vectrexes. And this breaks most emulators. And so that article from Malban discussed what were the different tweaks that you have to make to get it to work, and I implemented those last stream, and that's what we're looking at here on screen. So there's this concept of basically for the beam, we introduce kind of these states where we are ramping up, then ramping on, then ramping down, and then ramp is off. So that's what I call them here. With that, and then there was one other delay that we had to introduce, which was a delay on the setting the value for the X integrator, I think it was. Let me see. Or yeah, for the basically what I called velocity X here. Yeah, so when we read the value that's written to port A and stored into the X-axis integrator, that it needs to take some amount of cycles before it actually sees that value. Or at least that's what he wrote in his article. And we did it, and it gives us this as a result. I think you guys were not there last stream, right? You were not there on Monday? So this will be new for you, unless you watched the video on YouTube after. So, whoops. Okay, so let's say we take, this is the game, clean sweep. So now it should look, pretty decent. See, there we go. So this is the big, just look at how many lines there are on screen. It's crazy, right? Like this is a lot of lines for the Vectrex, and this would not have been doable using the BIOS routines, from what I understand. And so it looks pretty good now, right? But the way it looked before I had made my tweaks is like this. We can actually show what it looked like, because I have here, I'm going to try and make this a bit wider. So over here I have the ramp up delay, it's set to 5 cycles, and the ramp down is set to 10. If I bring those to 0, you'll already start to see some of the issues right there. You see? So this was mainly the thing that we had to do. There was also this velocity X cycles, and that is something we had to tweak, because once we had this set to 5 and say 10, you can see the font is all messed up, and part of that is introducing this delay in the number of cycles for the X-axis integrator. So once we have all those set up with these extra delays in there, we actually have a pretty good looking clean sweep. And this actually fixed other games as well that we knew were not quite rendering right. So this is pretty cool. It's cool in the sense that this looks like the right game. It's not so cool in terms of the code. It's kind of sucks having to add these delays in there. But it is, we are trying to emulate here, so of course it makes sense to do that. But there was something interesting I wanted to share with you guys in relation to this. So after my stream, Malban himself watched my video, and he posted a comment, and I just wanted to read that up on stream here because I thought it was very interesting. So he says, "Hi, I just watched your video, and I see you reached clean sweep. You already read some of my older texts. They may be partially right and or partially wrong. Since I am not an electronic guy, I never did any measurements with oscilloscopes." So for the record, I'm not an electronics guy either. So yeah, all that timing stuff is just guesswork, and it seems to work most of the times. Two things I'm pretty certain that are not really correct, or not completely anyway. So he's here saying via to analog timing delay issue. So ramp on off delay, clean sweep Vectrex start screen, shift delay. You see that phenomenon when printing text using homemade bidirectional text display routines. So he's saying that on these two things, he's pretty sure that he's not completely right in what he describes. For the ramp on off delay, he talks a bit about it later down here, so we'll talk about that. And the shift delay, well, I didn't really introduce much of one, but I'm sure if I try Moonlander, we'll probably see some issues with the font rendering. Or we should anyway. So he says, and probably sadly many other delays I introduce in vid also. This does not mean that emulating the Vectrex using those delays does not give pretty good results, but I don't think it is alone the correct emulation anymore. I haven't as yet come up with another better solution. I kept vid as it is. I haven't really tried hard. I have kind of a vid burnout. from what I understand, he spent like the better part of 2 years or more working on it, so I can understand that. This is where you might come into play. Please emulate better than vid so that I can copycat your solutions. It's kind of funny to say. I don't know if I'm going to be able to do much better than what he did. But anyway, his reasoning. So in terms of ramp on off, he gives here a link to this link where he talks about installing a 19-inch, attaching a 19-inch monitor to his Vectrex. So he says, I bought a 19-inch arcade monitor and connected it to the Vectrex. And only by connecting a set of different kind of monitor, Vectrex display changed dramatically. Not as screenshot, but also clean sweep doesn't look right. So he's saying that right off the bat with the 19-inch monitor, clean sweep doesn't render correctly. It seems the arcade monitor is in many ways faster than the original Vectrex monitor, since many games actually look on it more or less like on an emulator without delay settings. So what he's saying is that these extra delays, they don't exist with this 19-inch monitor. So like basically, I'm guessing what he means is that the beam moves almost immediately when you tell it to start moving. When you write values into the integrators, it just starts taking them. If you tell it to turn on the beam, it turns on right away. Tell it to turn off, it turns off right away. And he says that you might say that the monitor is, sorry, no. So basically, what I'm saying is that since most games use the BIOS routines, and most of those BIOS routines take these kinds of hardware, different idiosyncrasies into account and put extra delays in there, most games look okay on a 19-inch monitor, but games like Clean Sweep will not. So just to keep reading, he says, you might say that the monitor is also part of the complete Vectrex system and thus part of the emulation package, which I heartily agree to. But the place in emulation where one attaches another monitor to the Vectrex is completely different to where the analog delayed values are placed in our emulators. So this is very true. So where we put our delays is I put the delays right here in the VIA chip. Now, of course, my VIA chip, I don't really have in my code right now an abstraction that would represent the screen itself. Like I don't have like a screen class, that tries to emulate the screen's behavior. And I'm very tempted to do exactly that, because right now I'm putting all these delays in the VIA chip as though it were the VIA that would have these delays, but it's not the VIA. The VIA is just a chip that sits somewhere between the CPU and all the other peripherals, including the screen. And it's driving this screen. But I'm putting delays here, and actually what I should be doing is putting the delays on the outside, like in this kind of screen object. Because then, technically we could say, okay, well, we've attached a Vectrex 9-inch monitor, but if we wanted to, we could try to emulate like this 19-inch more modern screen and remove the delays. It would be, let's say, the version that has no delays, and maybe that, what am I thinking? The version with no delays could represent kind of like our baseline, and then we would have the special one that introduces the delays that a real Vectrex screen adds in there. So it just kind of keep the code a bit cleaner and put the delays in the right place, I think. And I think that's what he's getting at. That his emulator is similar to mine. He put the delays probably in his VIA code. All right, so what does he say here? Another example, Vectrex on arcade monitor is here. At that timer location, you see a Vectrex start screen. And let's actually go take a look at that. Okay, wait, it didn't go to the right time for some reason. Oh, because of the extra quote at the end. Here we go. So I think what we're supposed to notice is that there's this offset. Let me refresh that. I always have some trouble playing YouTube videos while on stream because of the incredible amount of CPU usage. Just pause there. Come on.
I'm going to talk about this.
Wow, that's crazy. Okay, I think I got it. Right, so... Well, to be honest, I don't really see what's wrong here. Another example, at that timer, you'll see a Vectrex start screen, and see how the Vectrex letters are placed wrong. Slight drift to the right. This is exactly the non-delay behavior, only by using another vector monitor. Oh, okay, yes, that's true. So you see how like there's this space here that's larger than the space on the right side? Everything is more shifted to the right on the screen. And he's saying that on a real Vectrex screen this doesn't happen, but on a newer monitor that you attach, this happens because those delays don't exist. So like even the rendering routines in the BIOS, for at least for font rendering, were written against this 19-inch monitor and the delays that came from there. Which is true that when you look at the rendering, font rendering routines, there are very specific cycle counted delays in there. So it makes some sense, that would be based on the actual 19-inch monitor that was attached. And there's no real surprise, right? Like the Vectrex was not a home console you attach to any TV. It came with the screen. So it would make sense that it was done that way. And then here he talks about the shift register, and he actually says that he put in a bunch of different, I put 8 different VIA, also different manufacturers, into one of my Vectrex, and it never made any difference. For that reason, I don't think that the VIA chips use different shift register delays. So basically, I don't really have shift register delays, so I don't think this really applies to me so much. He says, that being said, Vectrexy is always looking better. Greetings from Germany. So thanks, Malban, for writing and this very interesting post. And I think it will change something for me. I will try to move this code into some kind of, at least I'll try. I'll think about doing it. Some kind of like a screen representation. So I never even kind of committed this code since last stream. So let me just take a look at the changes I had made. Oh yes, illegal memory device. We could definitely get that committed. This was required for clean sweep because clean sweep actually makes accesses into the illegal memory range. It's the first game that does that I've tested, the first commercial game, and I needed to map this because it was the only piece of memory that had not yet been mapped in my memory map. So it's in this illegal range here. So once that was in there, and I basically ignore accesses to there, clean sweep actually works. So here, let's stage that. Here I need to take off this these optimize on and off. Okay, so oh yeah, this was for debugging purposes. Yes. Okay, I'm gonna go fix that in the code. So memory map. Take this off. Take this off. That off, and back our assert. Oh no, I made a mistake. Hold on. I deleted the wrong thing. That's what I want to delete. Okay. Oh, and the no inline. Yeah, I changed this also to an assert message just to give a better message. It shouldn't really happen anymore. In fact, now that I've mapped the entire range, I don't think this can ever happen, but whatever, I'll just leave the assert with the better message. Okay, so there's this change we can push in there. and this also goes with the illegal. I'm not going to put this via frame update. That doesn't go with this change. So I think this covers the illegal memory device. We include it. We have a member of it. We initialize with the memory bus. We just did this. Okay. Add. So I'll say add illegal memory device for the bound to handle thanks for that that info, Lisp gamer. Add illegal memory device to handle legal memory accesses. Clean sweep makes accesses in this illegal memory range. Let me just put that in my comment because so that's it. It's D. Allows to run. Okay, commit this. Let's go to the next thing I'm going to commit. Yeah, this is just nothing. Okay, I'm not going to commit this, but I'm going to hold on to it locally. If I put log, then clean sweep doesn't run because every illegal access will get logged, and just the cost of the printf slows us down too much. But I like to have it on log for development purposes because most ROMs don't do crazy things like that, and it helps me to find bugs and stuff in my emulator. Okay, so I had added this frame update. This is something that was a little bit annoying, and I was thinking about it. I did that because I wanted to be able to add imGUI sliders on some of those values, and I need to do that only once per frame. And I didn't have a once per frame function on my VIA chip, so I added this frame update. But now it's like a little bit, I realize I have a little bit of an inconsistency across my emulator, and I was wondering if what I should do about that. So I have like, let's see, not in the engine, but like my CPU, it does not have an update, but it has an execute instruction. So this we call as many times as we can. I have an engine client that has a function called update, and this is like basically, it should be like a frame update or update frame or something. It's given a frame time, it gets called once per frame. That's sort of the idea behind this. And so like I think I have a few update functions. Let's see. So my debugger has an update function that's called once per frame. And then I have a whole bunch of other functions called update in different classes that are not frame, like are not for one frame. You know, like my shift register has one, my timer classes have one. So that's what I mean by in terms of like a bit of a confusion. And then the worst offender is in the VIA, I have a function called update here, which is again not once per frame, like the shift register, like the timers. It's given a certain number of cycles to execute. And then I ended up adding this function called frame update. So see, there's a lot of inconsistency in my naming. So yeah, I'm thinking of maybe. I kind of like frame update, and maybe that's what I'm gonna do. Is I have only a few cases to update if I call them frame update. Like my debugger here, just change this to frame update, or maybe update frame. I don't know. Whatever makes more sense. I kind of like frame update. I don't like update frame because it says it gives the impression that the purpose of the function is to update a frame, whereas it's more like this is a frame update. You know, it comes from the fact that it's called once per frame. In Unreal they call it tick. But yeah, so maybe that's what I'll do. I'll call this frame update. Same thing in my engine client. So this becomes frame update. Tick, you're suggesting the name from Unreal. I actually never really liked tick. Because for me, tick is like, you know, one unit of, you know, a clock, right? Or whatever tick you define it to mean. And so it always seemed a bit weird to me to call the function tick, because it's not happening, you know, it's not for one tick that you do it. So frame update here. And isn't it fucking annoying? What do you mean? The name? Oh, yeah. Yes. Everything does have a tick in Unreal. Yeah, no, I got that. But yeah, that's the names that Epic uses. Okay, so that builds. So I think that's pretty good. Of course, that's going to introduce a whole bunch of changes now. That's all right. Yeah, this shift cycles thing, I'm gonna get rid of it because in the end, changing it did not actually help at all. So I'm gonna get rid of this. For me anyway, like playing with the shift register delay did not really do much. So I'm gonna just revert this change, which means I need to also fix it in the via. Pin? Sorry, I don't understand. What did you learn today? I stream well to your phone. I'm glad to hear that. I mean, I can't really take credit for Twitch's infrastructure, though. But one thing I know is that since I became an affiliate, apparently that means that my stream is supposed to be available at different bandwidths. So like, you know, if 1080p is too high, because that's what I stream at, if it's too high, apparently you can choose 720 or something else. Oh, okay, yes. Right. If you have a weak pointer in Unreal, you can call the pin function and it'll return a shared pointer. And in C++, if you use weak pointer, it's what is it again? It's lock, the function. Right, yeah. So basically, it attempts to return a shared pointer if the weak pointer, if the thing that the weak pointer is associated to is still, if there is still a shared pointer left to the thing, then the weak pointer will actually be able to return one. Otherwise, it returns a shared pointer that is compares to null. It returns true when you compare it to null. Another function name I like, I've seen in some code bases, that as opposed to update or frame update or tick, is advance. You know, basically you're saying this object now needs to advance in terms of time, and I kind of like that concept as well. That's another name I like. Yeah, 1080p. Do you have other options? Are you able to choose from a different set of resolutions? I'm looking at this here, trying to think what I want to do with this. Yeah. Yeah, I'd seen it in the context. I think it was Havoc's animation system that uses the word advance, because in that case you really are advancing animation, and almost everything in an animation system deals with advancing in terms of time. So it made a lot of sense in that context, but yeah, I can see what you mean. But I think the idea is we're advancing time, so I'm calling this function with the amount of time we are advancing in time. So if you want to do something related to that advancement of time, here's your chance, you know? But yeah. I think I'm going to call this not analog value store. I'm going to call it like a delay or delayed value store. I think I like that better. Maybe just a delayed value. No, delayed value store is fine. I can't put this 6 here. This really should be initialized to 0. And let's see here. And I'm going to go here and put update just to kind of continue with what I have, but I'm going to just assert. I'm going to use actually an old school assert, because I know we're going to pass it with 1. And I'm going to like address the fact that we have that in different places. Okay, so then that means that Twitch is not offering different options for bandwidths in terms of my stream. And what I read is that is guaranteed for partners, but for affiliates, it's like it depends on, you know, different factors, whether or not my stream will get that option to it's basically what's the word I'm looking for? Transcoding. All right, man. Have a good night. Thanks for hanging out. Okay, so let's make a file for this. It is source, right? Yeah. We'll call it delayed value store.h. Simple value container that on which we can assign values, but that value will only be returned after an input number of cycles. Okay, so the other thing here is that we have the ramp up delay, the ramp down delay set to 5. We need to initialize yeah, these should be okay. Hold on a second. All right, sorry about that. Okay, so yeah, where was I? Looking here. Yes, I wanted to add. Yeah, I see. Okay, so basically these are statics, but really should be const. These are really constants. The only reason why I'm making them static is because I want to be able to tweak them. I'm going to put a little to do here. Make these conditionally const for shipping build, whatever that means. For now, I'll just leave it like this. I'm going to move this up here. And what I need to do is I need to go down to where we set velocity x. And I'm just gonna do this. So every frame, yeah, that's better. So every frame will do this, and then I'm just gonna write back write the value that we've tweaked into the cycles to update value here. And technically I should do this at least once when we initialize. That would make sense. So let's do this here. It doesn't know what cycles t is, and unfortunately I think I have it in my base.h. Not a good place, but whatever. Oops. Okay, so let's see if I've broken anything. All right. So we draw. That's it. We draw while ramping down or ramp is on. Okay, no, while ramp is on or ramping down. Not draw, sorry. Move beam while ramp is on its way. Drawing is different from moving the beam. So we move beam while ramp is on or on its way down. Okay, so this here is the kind of state machine to control whether we are going to up or down. And this is going from on or off. Okay. So I'm going to be committing this as is, and then I'll make a separate task to move this functionality out into some kind of screen abstraction. All right, so for this, I'm going to say the main focus of this change is here. So we're going to say via introduced delays in ramp I'm going to say ramp and X integrator. we introduce delays in time it takes for ramp and X integrator values to change. Fixing timing related rendering issues. This fixes games like Clean Sweep and certain font rendering in general. And some squished renders. Like in what's it called again? Berserk. Okay, I know we're not doing a ton of work tonight, mostly just cleaning up the changes from last stream, but this is part of development, right? I do tend to try and do this off stream, but I didn't really have a chance, so. So if I did want to move this, I'm just trying to think about what it actually would mean. I think a lot of what I do in my render state would be pushed. Yeah, probably all of this would get moved when I think about it. Let me see, XY offsets. Yeah, we would write to this register, let's say, on the screen. I mean, technically it's not a register, but yeah, I kind of, that's the thing, I have to think a little bit about what these values represent. You know, I say it's the screen hardware, and I guess it sort of is. It's the hardware that drives the screen. So there's like this brightness setting, the integrators for X and Y, which I call velocity here, and this XY axis integrator offset. Yeah, I guess all of this would get moved into the screen. Blanking as well. Because blank is also kind of like a way to control whether we draw or not. So that too, I guess, would go on the screen. And of course, all the delay stuff would go in there as well. So yeah, the very fact that I have this separation in my data members where I kind of knew this all had to do with rendering, I had already grouped these together because these logically go together and don't really have, they don't really belong in the VIA chip per se. You know, the chip itself doesn't have a notion of position and velocity and like brightness and all that. It just kind of is connected to a screen. It doesn't, though, talk to these other peripherals. So I would imagine having, let's say, a screen member here. You know, like if I really wanted to make this be more realistic, I would have done it a little bit differently, right? I would want to like connect inputs and output pins of the VIA and have those connect to some kind of bus, or just have a way to connect different like inputs and outputs to different ports of chips. But actually that is very cumbersome. It's cool in the sense that it's really much more abstract and, you know, much more you know, the separation of what is a chip and what it does, it would model the hardware more accurately, I suppose, or more realistically. But I think that it would just add a lot of confusion, a lot of indirectness, and actually it would be slower than what I do now. Right now, I pretend that the VIA has a shift register and has a timer. Although actually the VIA does have timers and shift registers, so that what I'm saying doesn't make any sense. But in terms of all the render state, that wouldn't be inside the VIA. And in fact, all this joystick button state, all this should not be inside there as well. Instead, I should have in here a mux, and then the mux would be connected to different components, like the joystick button state stuff. You know, that's something I might have to do when I think about how I'm going to handle audio. So I may end up putting a mux in here. Yeah, I'm gonna have to revisit some of this stuff when it comes to representing audio and how to do that kind of thing. But anyway, yeah, I'm not too bothered by the fact that I have this stuff in here right now, but this should be moved out, and this would clean up the VIA code. And then I guess it would become, how does this work again? Oh yeah, I get a render context in here. And I guess that would be passed on from the VIA to the screen. And then the screen would put the lines in there. Yeah, that would make sense. If I follow the render context. Yeah, we see we do it right inside here. So basically a lot of this code would disappear, and what we would do is in here we would say, okay, take the screen and tell it to update for a cycle, you know? All right, let's see. Let's start adding the screen and see how it goes. Say there's an actual 9-inch screen that comes with a Vectrex, including delays, hardware delays when moving the beam, etc. Okay, don't need those there. Yeah, I don't use array. Alright. So we're going to want an init and an update. We're going to want cycles and the render context. We're going to want to move the frame update actually in there. Yeah. Okay, so we created those. It doesn't know what render context is. I think render context is an engine client. It is. Okay. Alright, so I think we can. I'll just leave it open for now. Okay, so screen it. Okay, so move that into here. So there's a lot of just moving code around, so got to do this right. So all of this breaks, of course. What I wanted to check was, yes, this guy. I'll just start moving it here into the init. And frame update. That looks like that. Okay, we're going to want to include screen.h, and then we'll add a screen down here. And then what we want to do is okay, yeah, some code here that isn't quite where it should be. This last position should be there. that we can use it down here. The delta here can totally go back. Delta is here, so this should be vector 2. Right? I don't use delta anywhere. Yeah. And this is all gonna move. It looks like I'm gonna have to pass in whether integrators are enabled into the screen. So that's fine. I'll do that on update. Integrators enabled. So say like this, cycles in the render context. Actually, I'm going to do this a little bit lower. I'm going to come here. I need to move these. Into the screen. This should compile the screen CPP, and it does. Now, we're getting very, very close. Yes. Okay, so we're going to need to tell the screen to move its beam to 0, 0. I'll call this 0 beam. I want to add also, I'm thinking I'm going to do this differently, integrators set, integrators enabled. I'm going to remove it from the update. Hey, what's up, Synchron? The emulation goes well. It's going really well. Just doing a little refactoring here. What are the shaders for? You're looking over here? Is that what you mean? Or have you like looked at the code? Just wondering where the question came from. Yeah, that folder. So basically I implemented the rendering for the emulator using shaders. And what I do is I try to emulate what the CRT actually looks like on a real Vectrex. So I simulate the fact that you know, the beam, when it draws, the lines that it renders will fade to black over time. So I actually never kind of clear the screen. I'm always drawing into a texture that is used at every frame, and I take that and I have a fragment shader that brings all the pixels down to 0 over time. So it gives a very kind of realistic effect. There's a bit of a fade out, a little bit of a flicker, and I also do some blurring to give a bit of glow. So you haven't seen the emulator running yet, I assume, right? So if you just wait a second, I'll, you know, once I get this compiling again, you'll be able to see it running. Set blank enabled. So what we're going to do in the via here, did I need to write some form of device driver for the graphics? I'm not sure I understand what you mean. Why would I need to write a device driver? Like I'm not actually. If I think I understand what you mean. If you like, I'm not actually trying to control the, I don't know, the beam of the screen of my actual screen. I've just got like an OpenGL, like I've got an SDL, what do you call it, like an OpenGL context attached to a normal window, and I'm just using OpenGL to draw lines into buffers. Maybe I don't understand the question. But you know, like how like most emulators work, right? Like, or maybe you don't there, but basically like a NES or a Super NES emulator, you know, to emulate the raster, you just basically want to draw into a buffer and put that on screen. This is kind of similar. It's just that the Vectrex is not a raster screen, but it is a normal screen, a CRT with a beam that moves around. And so I just emulate that beam moving around by drawing lines into a texture, and then that just gets drawn, like rendered to the window that you see. So in terms of like a GPU, this code I'm working in right now is about as close as it gets, I guess. There isn't really a GPU, but what I mean by a beam, so the Vectrex is a console that came with this built-in display, and it's a CRT. It's a cathode ray tube display, like the old televisions, pre-LCD and plasma and all that. And in there is a beam, right? And like typically the beam is a raster that it performs like in a raster display fashion, meaning that the beam moves from top left to right, and drawing horizontally, and then it goes back to the next row to the left, and then draws to the right, and it does this until it's drawn all the rows, and then it moves back up to the top left corner. So that's how a raster display works on a CRT. For the Vectrex, they just removed that machinery that makes it move in that kind of raster-like fashion, and instead there's a chip on the board of the Vectrex that directly drives the integrators that move the beam around the screen. So very much like an oscilloscope, or any one of these displays where you have like this vector, like in a hospital when you see like that kind of classic heart rate monitor kind of thing that shows a beam moving. Well, at least the old ones would work this way, that this beam is being controlled from the externally and saying move from the left position to the right, and then show a blip basically for every time there's a heartbeat. That's how the Vectrex works. So it's basically like a series of abstractions, like if you're programming a ROM, like a game for the Vectrex, you basically just set up a bunch of vectors that you want to draw, and you kind of call this function that's in the BIOS, and then it knows how to send which registers to turn on and off on this VIA chip, this chip called a VIA, which is the versatile interface adapter. And then that chip is connected directly to the hardware of the screen, and it drives the beam's movement on the screen. And keep in mind this is 1982 hardware. So yeah, it's very metal. You know what I mean? Like, it's to the metal. It's there's not many layers of abstraction. There's no operating system. There's no it's really hardware. It's everything is connected, and it's analog hardware with all the subtleties that come with that. Okay, so this gets the update, and see the update is a lot simpler now. Which will populates the lines in the random context. Okay, this now of course will not compile because we have other bits of code that need to interact with the screen. Yeah. So these guys here, we need to be able to write these values out to the screen. I sort of have an idea about how to emulate a simple single CPU, but I can't really imagine how a more modern system, like a newer Nintendo device, would be emulated, since it has both a CPU and a GPU. In that scenario, the CPU never really draws a buffer. It dispatches commands to the GPU to do that work for it. Yes, that's true. A modern system, it's different, and what you do, there are different techniques for a modern system. So one of them is the HLE technique, the what is it called? A high level emulation. And what that is you look at it's about where you draw the line, right? So like, for example, you know, if you take, what did you mention here? Like a newer Nintendo device, right? So let's take like a Wii or Wii U or something. The system will like make calls to some kind of like operating system. I mean, it'll make an operating system calls for talking to the GPU, like for, you know, sending vertices, to uploading vertices to it, making draw calls. And one thing you can do when emulating is you can say, okay, I'm going to kind of intercept those calls. When a draw call is made, I'm going to go, this is very high level. I'm drawing the line very much up into, let's say, at the operating system level, and saying I'm going to take that and then translate that into how that should behave on a PC, right? So like I'll translate that into DirectX 11 code. Or you can go a little bit deeper and say, okay, no, I'm going to emulate the actual GPU itself, which is probably much more difficult, much more expensive, but would be technically more accurate, so to speak, right? So you're going to write this GPU core, and you're going to try to make it behave like the real GPU does, which is probably extremely difficult. Now that I think about it, I haven't actually written such an emulator, but it's really that's it. It's like, where do you draw that line? Now, from what I understand, if you look at emulators like Dolphin, which actually emulates the Wii and the Wii U, and the GameCube, actually, from what I understand, is they actually emulate a lot of the GPU stuff in shaders. And I think I was reading recently that they wrote this like Uber shader that handles most of what happens in the rendering side, all inside a shader. So there is a part, of course, where they need to configure the shader, and configuring it, a lot of that has to do with emulating how the GPU works. But for the actual drawing, they push that into this big Uber shader that takes care of it all. Yes, exactly. So you're talking about syscalls. I mean, I don't know how difficult it really is. Ultimately, you know, you're implementing a CPU anyway, and at one point you have to emulate the reads and writes to specific memory addresses. And assuming that a lot of these syscalls are jumps to specific addresses is probably not that difficult to intercept. I mean, because you're doing a lot of intercepting anyway, because you have to know, you know, which, like for example, in my Vectrex emulator, when you do a read or write, I need to actually figure out which device you want to talk to, because it's memory mapped. So you can almost think of it that way, kind of like the abstraction is memory mapping certain addresses to these high-level system calls that you have to emulate. I think there was an emulator that, like one of the first N64 emulators that was released, called Ultra HLE, that did exactly that kind of thing. The HLE technique. Earlier emulators had concentrated on accurately emulating all of the low-level operations of the target machine. This worked well enough for older consoles such as a Super NES. Co-authors Epsilon and Reality Man realized that since N64 games were programmed in C, they should concentrate on intercepting the far fewer C library calls instead of intercepting machine-level operations, and write their own code to implement the libraries. Thus, Ultra HLE software is in fact an emulator with some parts implemented as a simulation, and the technique is not used in purist emulation projects such as MAME. However, it paved the way for creating playable emulators which use complex graphic routines that require considerable computation power, which could be simulated easily with available PC graphics cards. So, you know, and then they say here, the high-level emulation has its drawbacks. It was only able to emulate approximately 20 games to a playable standard. Yeah, and then it says, however, on its release, it was miles ahead of competing N64 emulation projects such as Project Unreality. So, exactly. So, like, you know, it's a trade-off, right? On the one hand, if you can intercept these calls to high level, you can get something working that's very quick. much quicker than if you try to do the low level, but on the other hand, it can be very difficult because there's a lot of timing issues that may be relied upon by many games. These kind of subtleties are very difficult to emulate when you're doing this kind of emulation, or simulation as they call it here. So again, I don't have much experience writing emulators at this level. I've only written a Nintendo emulator, a NES emulator, and this Vectrex one. So both are older, simpler, and in both cases, I emulate as much as possible what's happening at the lowest level. I'm not really intercepting. And what's interesting is actually for the Vectrex, I could have intercepted. There is a possibility. Because there is this BIOS that is, it's burned in ROM, and most games make calls to the BIOS. So there would have been an opportunity for me to intercept these calls and do my own thing for the Vectrex. The only thing is that I can't really do that because a lot of games, not a lot, no, some games bypass the BIOS. So like exactly this game I've been getting on working clean sweep, that's a game that would not have worked at all because it bypasses the BIOS and does its own thing. So, all right, so here what I was gonna say is, set brightness. It's also, that's a uint 8. An XY offset. Oops. Yeah, I have zero experience just from watching and talking with others who make emulators on Twitch. What would be a good OS to write a report about? Not sure what you're looking for. Is this for school? Like what's the purpose? Is this for a class you're taking? Like an operating systems class? And you just need to like pick an OS that's not a desktop OS and just like read about it and write interesting things about it. I don't know. Let's see. Thinking about my own experience. So I had the original BlackBerry. The very first version of the BlackBerry was very different from the subsequent versions. It ran an operating system that actually executed like every program on that old BlackBerry. So it was black and white. It had this kind of rotary dial on the side, like a rotation. What do you call it? Like a wheel that you would use on the side with your thumb. and you would see all these apps, and each app was actually a DLL. It was a Windows DLL, like really this exact same format. You would use Windows, you'd use Visual Studio, and you would compile a DLL. You would link against a C library that they provided, and you had just a few hooks in your DLL to implement, and it was really simple. And you would just write in pure C or C++ if you wanted, and compile this Windows DLL and plop that onto your BlackBerry, and you had an application. And I actually wrote a game for my BlackBerry using that. So that was kind of cool. And then eventually, like, that was version 1, and then by version 2 they completely scrapped that and instead decided to use Java. Like they ran a Java runtime, like a mobile, or I guess a mobile edition or whatever, some kind of, you know, faster, like Java for devices. And then my application was no longer compatible. You couldn't use DLLs. It had to be a Java application, which made a lot of sense. But yeah, I mean, I'm sure it was the right decision. It was, you know, portable and cross-platform and easier probably for people. You know, you could develop on something other than Windows, so I guess that was part of it. But at least for that version 1.0 of their operating system, it was, you know, I guess they I don't even know how legal that is, but they basically took the binary format of a Windows DLL and used that to represent their applications. So that's kind of interesting. I mean, apart from that, I don't know. You know, you could do iOS and Android, I suppose. Those are not desktops. Although Android, anyways, whatever. What am I doing? All right, let's see if this works. So it builds. Okay, so far so good. But why does it matter if it's a dead project, right? You can write about any OS, even OSs that are long dead. It's just a report, isn't it? So this is the emulator, by the way. So you can see like there's a kind of like a glowy effect to the way the lines draw, and that's the darkening and the darkening effect that's going on in the shaders. And then I can play with a bunch of rendering things here. Like there is this the glow here can be controlled. The thickness and the glow radius can be controlled. We can make it a little bit tighter. Probably should be a bit tighter. Thanks, man. Yeah, I have some work to do on I have to go back to rendering, because I realized when I tried running my emulator on a high resolution display, which is my laptop, it doesn't quite render correctly. It doesn't look the same as it does on this desktop. And in fact, it's pretty obvious even just by resizing this window. You don't see it now, but there are discrepancies in the way it draws based on the resolution. And that's because I didn't actually write my rendering code in a resolution independent way. Specifically, it has to do with the way I treat lines. I rely on GL lines. Like I rely on how the driver is going to render lines. And the thing about that is that the way lines look totally depends on your resolution. If you have a really high resolution display, the lines will be, very thin. On a low resolution, they'll look very thick. So I don't get a resolution independent look to my lines. Right? It looks good on this screen because that's the one I developed most of it on, but it doesn't look as good on my laptop, which is a high DPI display. What do you mean? Is it? If you look specifically at how GL lines works, you don't really have much control. You know what I mean? On the kind of the thickness of the line and all that. I did write some code to be able to draw lines of some thickness, and I use it actually to do my blur. But there is always an overlay, a layer on top of that is just drawing the thin line that comes directly from the driver. So, I have no control over how that line's going to look. You know what I mean? And so what I need to do is I need to do my lines differently. I need to draw my lines as quads in 3 parts, and make my, the size of my line has to be drawn to some kind of, like virtual device coordinates. Like choose a virtual display and then draw everything against that virtual display, and then have it scale correctly based on the actual resolution. Yes, I would need to write some strips. Exactly. So like draw a line in kind of 3 parts, where the 2 ends are drawn, using some kind of texture, where it goes like smoothly in. So I get like a I guess a rounded end on both ends, and then in solid in between. So something along those lines. No pun intended. And yes, and more importantly, do it against some kind of like virtual resolution, so that when it scales, it always looks the same. Ultimately, that's what I'm trying to get at. It needs to look the same regardless of your resolution, but it needs to look good at every resolution. Because another way to do that would be, for me, like another way to think about it is, if I were to just draw GL lines to a fixed resolution texture and then just scale that to whatever your display is, that would give me a look that looks the same everywhere, except for the fact that there would be scaling artifacts. And then those scaling artifacts would just make it look terrible at most resolutions that are not exactly matching the resolution that I want. So I don't want that. What I want to do instead, though, is to draw my lines to the resolution that we have, to whatever resolution whatever size your window is, whatever pixel resolution you have, but make it look as good as possible and make it scale appropriately based on that resolution. So it's a mouthful. It's harder to talk about and easier to draw and explain, but I'm preparing to launch myself back into rendering and to solve that specific problem so that this really does look the same everywhere. You could also limit your resolutions instead of allowing window dragging. Yes, that's true, but I don't know. I like the window dragging. It always annoyed me when I have to use an emulator that limits the resolutions, like 1x, 2x, 3x and all that. I really much prefer when it can go multiple sizes. And the thing is, I get it for like, NES, Super NES, and any emulator that has to do, the pixel-based display. It's very difficult to make it look right at resolutions that are not multiples of the base resolution. I get that. But for a Vectrex, a vector display, that is not the case. We're drawing lines. So, that's part of why the Vectrex still kind of looks good today, because when you're dealing with vectors, it doesn't look pixelated. You know what I mean? That's what's cool. Like this 1982 machine, if you play it, you don't see pixels. So it seems to me like an arbitrary limitation to add to my emulator to say, oh, you must be some multiple of this base resolution. But yes, it would be possible to do it that way as well, and it would be simple. But I don't think it's going to be too bad what I want to do. Alright, so I'm pretty happy with this. This wasn't so bad. Why isn't it seeing the fact that I have these here? Screen. Okay. Yeah, so I kind of like this. We move this out into a separate class. It cleans up the via and it puts together all the things that have to do with with basically how the hardware for the screen would work. We deal with zeroing the beam, with the blank, integrators, the brightness, all of that. And the goal of the screen is to basically draw output lines into this render context. So that's pretty cool. There it is. All right, so let's get this checked in. Oh yes, and one thing I wanted to do. No, it's okay. I'll leave it like that. Oh yes, I need to clean up all of this crap. Okay, looks good. Grab all this. I'll say moved out render or screen rendering code from via to a new screen class. Maybe not screen rendering, but the screen class model is the image Vectrex screen, including delays, and is responsible for moving its beam and drawing and outputting lines that get drawn later. All right. So I'm not going to really do much more tonight. Maybe we could just test a couple of games and then I'm going to call it a night. So let's just take a look here. Was there something here I wanted to test? Well, you know, I do stream very regularly, Cinecron, so if you want to catch me, Mondays and Wednesdays at, I usually start at 9 Eastern. So if that works for you, just follow me and check me out on those times, and you can see me coding in C++. Oh, you just stumbled upon my stream when you were like Twitch surfing? Oh, okay. That's cool. Let's see if this old school demo actually works. Old school. Well, thanks for the follow, man. Appreciate it. Why can't I find this demo? Oh, I think it's actually working. The vector tunnel. The 3D animated star. The scene graphics. Yeah, the text is thin. You know, that would be the demo, right? That's not really. It's not using, I guess, the text rendering commands, like the text rendering BIOS routines. The end. I think he's doing his own thing for rendering font here. If we turn off the blur, it might be slightly more obvious. But yeah, that's so this is actually working. That's kind of cool. Because like last time I tried it, it said no boot, and I'm gonna assume that the reason that it's working now is because I've implemented IRQs, IRQ handling. So that happened not too long ago, and I think a lot of these no boots were just waiting for IRQs. So I'm gonna say here, good, I guess. Let's try this one, Arcanoid. Oh no, this was a sound one. Yeah, the sound ones are less interesting for me. I wonder if this one works. Battle Earth Terror Hazard. So let's try the first one, version 1. So what I had written for this one was, it looked like it worked, but the bottom render was squished. But now I think it looks, oh no, there's something, oh no, that's good. Let me make this a little bit bigger. Whoa, what the hell? Oh, I can go up. Fuel low. Okay, I see. So when I'm down, my fuel goes up. Then I go up. What do I need to do? Like capture these things? Hey, BD. Okay, well I don't really understand this game, but looks pretty cool. Death. Let's try the other versions. So the other versions, so I think this now looks better than it used to. This one here I had an illegal instruction, so I might still have that. Let's see. Oh, no, this one's working now. Although this font render here doesn't look quite right. So it seems like Manu has his own font rendering routines. So this is kind of odd here. I wonder if like this has anything to do with these delays here. Interesting. So it looks like there is at least part of it that's affected by these timing delays. But at least it doesn't crash. Bottom render cutoff for version 4. Ooh, getting fancy. Okay, so this definitely, we still have the problem here with this time low, fuel low. Oh, now running out of time. But yeah, there's definitely something with the render here. So maybe my timings aren't quite right. We'll see if that shows up in more, under more conditions. So this is okay. And I'll just make a note here that the font score render not quite right. This game flickers a lot more than the Pac-Man thing. Maybe. The interesting thing about the flicker is that it's somewhat related to, like, it is somewhat related to the frame rate of the game itself. Because the point in time at which I actually render a screen can differ depending on the frame rate. So, like, if I make the screen larger, you might see more flicker than if I make it smaller, because it actually takes longer to render. And there's not that much I can do about that. I mean, but the effect is not super it's not supposed to be really pronounced. It is still time-based, the way I bring the colors down, but there is a discrete moment at which we actually do display the screen, and that moment can be at different times in terms of when we are fading down to black or not. And so sometimes we see a little bit more flicker than we would normally see otherwise. But I'm totally fine with that effect, because it really does feel a lot like a real CRT display. And actually that flicker can be partly controlled. Like if I bring this game up again, if I make it really big, right? it's the thing is when you're dealing with this kind of display, this kind of raster display, there isn't really a frame rate the way we think about it, because there's no real concept of a frame, right? The concept of a frame, when we talk about frame rates in games, comes from the idea of a raster display, right? Like a raster screen that displays 60 frames per second means you're getting 60 times this raster of a frame buffer, like to the entire screen, right? So let's say you're working back in the old days, you'd have a 480p display. That meant that you were going to get 480 rows of raster, and that's one frame. And then during the vertical retrace, you're filling up the frame buffer with the next screen to render. And you're doing that at a rate of 60 frames per second, for instance. Now with the Vectrex, there is no raster, right? There's just a beam and you're moving the beam around. Now, the only timing imposition you have, yes, and so I'm getting to that. So basically there is one thing though. This beam has to be, there is like you can't just move the beam endlessly. Like what happens is that if you move the beam and just keep moving around, eventually there is a drift that occurs and the beam starts to move in very erratic ways. It starts to skew in its movement. So what you're supposed to do on the Vectrex is you're supposed to reset the beam back to 0, 0. There is like a hardware reset that brings the beam back to the center of the screen, and it's the only way you can, it's kind of like an anchor point, right? And you have to do that at a certain rate, and that rate is at around 50 hertz. Like 1/50th of a second is about as much time as you can do work and move the beam, and within that time you have to bring the beam back to 0, 0. So it's actually less than a 50th. So if you think about it that way, a frame is about a 50th of a second. It's actually less because you got to take into account the cycles it takes to move the beam back to the center. So and how many cycles it takes also depends on where the beam is. So there's some worst case, like if the beam is in the top right corner or something, it'll take the longest time to get back to 0, 0. How many cycles that is, that's pretty much how many you have to factor into your frame. And so less those number of cycles, you have a bit of time to start moving your beam around and doing your game logic and drawing and stuff. So we say that the Vectrex has a 50 hertz frame rate, but it's not a frame rate that's really tied to raster, So here, this flickering, I have this darkened speed scale here. So if I lower it, you can see that the flicker starts to disappear. You see? But in return, what ends up happening is you end up with this. You see all the trail here, and if I bring this up, the trail starts to disappear. And if I go really high, you get crazy flicker, but no trails. So there's kind of like a sweet spot somewhere in there. This is not behaving correctly because I'm not even hitting 60 here, but if I just do this here, yeah, crazy amounts of flicker, or like very little or no flicker. Let's try this birds of prey again. Why can I not move? Okay, oh, okay, I can move. This is one of those games where you have to move left and right. And this is one of those games actually where the trails can be difficult. Let me see if I turn off blur and speed this up, whether that will make a difference. Yeah, this makes a difference on how playable this game is. One thing is that this game is a bit hard is that when they fire, it looks a lot like the stars that are moving in the background, and there's a trail on those, so maybe that's supposed to be there to kind of add to the confusion, but yeah, I want to avoid the per game configuration thing, but that's definitely an option. So there's a whole bunch of ROMs by Chris Salomon that are, it looks like to be all kind of sound. Basically, he made ROMs where he plays music. So none of those are ones I will test, but when I implement sound, I'll be very interested to hear these play out. I should really split out all the sound ones. Madonna's Get Into the Groove. Mike's Molecules demo, 1985, eh? Pokemon demo. Yeah, I think these demos are just rendering Pokemons. We can try them. There's one. Again, this is from Manu, so it looks like I've got that issue with the rendering of the font. So his font rendering relies on certain timings that I may not be getting right. Okay, that looks better. Let's try demo 3. Ugly ass Pikachu. Whoops. There we go. Although we're missing stuff at the bottom here, but anyway. This one's Psyduck's Eyes. Okay. There's so many. Starfire Spirits, what's that? Oh, I picked the wrong overlay. Yeah, my overlay detection mechanism is not amazing. So I picked Star Castle because this is called Starfire. Oh, that's pretty cool. Well, those look like TIE fighters. Sight speed, fast. Medium, fast. Okay. And that's firing. Oh look, I'm an X-Wing. That's pretty cool, right? I mean, I have to say it again, right? This is, we're talking hardware from 1982 here, right? Shield's gone. And I died. One of the funny ones is the Vectrex boxing. Vex Sports boxing, is that the one? Maybe not that one. Let's try this one. Check this out. I think it's a 2-player game. Yay! Knockout. Let's try that. V1 Vector Vaders. And then after this, I'm gonna call it a night. Whoa! What was that? This looks just like Mindstorm. Let's see. Over 12 years have passed since the release of any new Vectrex game. Things change. Oh, and I have a SWI. It's weird. What happened before it was so odd. Okay, so this is, I haven't implemented SWI yet. Alright, so I'm going to stop here, guys. Thank you very much for watching. And I didn't even realize I was running that. So yeah, next week, I'm not quite sure what we're going to work on yet. I'm going to think about it. Still a few games that are not quite working the way I'd like on our main list, but we're getting really close. Like, you know, I'd say most, maybe. When I look at all the base ones here, most things are working. I have a couple that are not working that are like different versions. I know if I implement SWI, I think that's like the last instruction I really need to implement. Yeah, I actually think these no boots are not quite right anymore. Like 3D Mindstorm, we actually did get that one working. So this is not really a no boot, so I just need to update my See, look, this is the no boot, right? This is because it's expecting a like if I go to SDL engine, my hack simulate 3D imager here, just enable that, then that game will work, and probably the other one as well. Let me see. Anything that requires a 3D imager needs this hack right now for me, and it's not quite right, but anyway. But yeah, so I just need to update the table as well. So here's 3D Mindstorm. So see, it's working. We need a 3D imaging goggles for it to look good, but it does work. So that's no longer a no boot. So let me fix that here. Okay, I'm just going to delete all this here. And via not implemented, I think that's not true anymore, is it? Oh, sorry, that was 3D narrow escape. Those probably work as well. Let me see. There's 3D narrow escape. It's funky. All these 3D games that require the imager, I definitely have some work to do to get those to look good. But they're no longer no boot, so they're basically imager games. I'm gonna have to tackle those if I care at some point. No, it's not it, but I want to try this one. So yeah, this one is unexpected value for 0 bits. What is this again? Why does it say 0 here? I think I did some kind of weird search and replace. I must have done something weird here. I think this should read CA 2 bits or something. Okay, so there's something weird here. And then what was the other no boot? And here is Heads Up Action Soccer B1. Nice, this one does actually hang. So yeah, we could try to fix this one. Oh, no, it doesn't hang. Right to enable interrupt not supported yet. Okay, so I'm not handling CB2. So that's possibly why this is not working, and then it crashes. So yeah, this we could work on this next time. It means that the CPU is waiting for a certain interrupt that I'm not handling yet. So not really a CPU, no boot is a, I guess we could say via not implemented. And I'll say what was the error again? Actually, let me try something. I think maybe what's happening here is I need to turn off my hack 3D simulate 3D imager, because that's like basically pressing joystick 1 button 4. I don't think that should cause a problem, but I just want to rule it out. So this stays on the title screen for a very long time, maybe playing a song or something that takes a long time, I don't know. Okay, and then we come here and we get a right to enable interrupt not yet supported. So this is good. We know we have to fix this. Okay, I'm gonna stop here. So yes, thank you very much guys for watching, and if all goes well, I'll be streaming again next week on Monday. So thanks again, and see you next time.